Today, we're going to pull back the curtain on an invisible force. It's something that dictates everything from why a skyscraper stands tall to how a race car hugs the road. It's the secret to balance, and believe me, it is hiding in plain sight all around us.
Have you ever built a tower of blocks that seems totally solid, but then you add that one last piece and the whole thing comes crashing down? Why does that happen? Well, it turns out the answer lies in a single, invisible point that holds the key to literally all stability. So, what is this big secret of balance? Let's dive right in and get to the heart of it. We are going to uncover the center of gravity. Okay, so this hidden point is called the center of gravity. Here's the big idea. No matter how big or weirdly shaped something is, you can imagine that its entire weight is concentrated in one single spot. It's the point where gravity really gets its grip. To make it super simple, just picture yourself trying to balance, say, a pencil on your fingertip. You know that one magical spot where it just sits there and doesn't fall? That is its center of gravity. It's the object's perfect point of balance. That's why you can think of it like an invisible anchor. The location of that anchor is what determines whether something is going to stand strong or just tip right over. Seriously, everything depends on where that one point is. Okay, so if this point is totally invisible, how in the world do we actually find it? Well, it's actually way simpler than you might think. It all comes down to a pretty clever little experiment. Let's check it out. This is the fun part. You don't need any fancy lab equipment, just a few everyday items. We're going to go on a little scientific treasure hunt to find that invisible anchor we were just talking about. The real beauty of this is how simple it is. So, you take any flat, irregular object, like a piece of cardboard, and just let it hang freely. Then you hang a plumb line, which is really just a weight on a string, from that exact same point. Now gravity pulls that string perfectly straight down, and here's the cool part, that line always passes through the object's center of gravity. You just trace that line, do it again from another spot, and where those two lines cross, that's it. And boom, you found it. That one spot where your lines intersect is the center of gravity. If you were to try and balance the object right on that point, it would sit there perfectly. You've literally made the invisible visible. Pretty cool, right? All right, so we know what it is, and we know how to find it. But why does any of this matter? Well, this is where it gets really interesting, because this one point is the secret behind everything from how a race car can take a turn at high speed to how a tightrope walker stays on that tiny wire. So here's the most important takeaway. Where that center of gravity is located decides everything about how stable an object is. Is it high up? Is it low to the ground? The answer tells you whether it's going to be rock solid or super wobbly. And really, it all boils down to two simple rules if you want something to be stable. First, you want its center of gravity as low to the ground as possible. Second, you want its base to be as wide as possible. I mean, think about a pyramid. That's the perfect example. An upside-down pyramid? Not so much. And this makes it crystal clear. A race car is ridiculously stable, right? That's because it's built super low to the ground with a really wide base. Its center of gravity is just inches off the pavement. But a double-decker bus, it's much taller, which raises its center of gravity and makes it way less stable. That's exactly why they have to take corners so carefully. Okay, so here's the rule that governs everything. Just imagine a vertical line dropping straight down from the center of gravity. As long as that line lands somewhere inside the object's base, it's stable. It'll stay upright. But the second you tilt it far enough that the line falls outside of that base, well, gravity takes over, and it's gonna topple. It's that simple. So, when you boil it all down, everything we've talked about really comes back to this one idea. A single, invisible point that governs all balance. If you understand this one point, you understand the secret to stability itself. So now you know the secret. Think about it for a second. If you were designing a skyscraper, or a chair, or maybe even a toy, how would you use this knowledge? The power to create perfect balance is now in your hands. What would you build?